In this video, let's take a look at one more example of graphing a polynomial. Let's graph f of x is equal to x times x plus 3 squared times x minus 5 cubed. First, let's begin by finding the end behavior. To do that, we will need to find the degree and the leading coefficient. The degree for this polynomial, we're going to use the trick. Take each x value with its exponent. So it's x to the 1, x squared, and x cubed multiplied together. Remember, when the bases are multiplying, the exponents are actually adding. And so when I add the exponents, I get 6. So this is a degree 6 polynomial. Next, I need to find the leading coefficient. All of them in front of the x just have a 1, so my leading coefficient is 1. So this means for my end behavior mini graph, my degree is even, my leading coefficient is positive, so that means my end behavior arrows are going to go up, up. Remember, there's 4 cases: up, up, down, 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 up, and up, down. Make sure you have those 4 memorized. Next, I need to find my zeros. Take each part of the expression and set it equal to 0. So I have x equals 0, x plus 3 equals 0, and x minus 5 equals 0. X equals 0 is already solved. Subtract 3 to the other side and I get x equals negative 3. Add 5 to the other side and I get x equals positive 5. Next, I need to find my multiplicities. My multiplicities are the exponents on each of those zeros. For this example, I have x equals 0 has exponent 1, x equals negative 3 has exponent 2, and x equals 5 has exponent 3. So nice and easy. Multiplicity was 1, 2, 3 for this problem. Next, I need to determine if my function is going to cross or touch the x-intercepts. So if my multiplicity is odd, it's going to cross. So 1 is an odd number, 3 is an odd number, so that's going to cross. But 2 is even. Even represents a touch. Next, I need to calculate the y-intercept. To find the y-intercept, I'm going to plug 0 into my expression and solve it for y. So I have 0, 0 plus 3 squared, 0 minus 5 cubed. Again, it doesn't really matter what all of that calculates to because I have 0 on the outside on the left. 0 times anything is 0, so nice and easy. And now I'm ready to do a sketch. Alright, I have zeros at 0, negative 3, and 5. So 0, negative 3, and 5. My end behavior for this particular graph was up, up, so leaving some space, I'm going to draw my up arrows. So starting in the top left corner, I'm going to draw, draw, draw until I hit the first point, negative 3. I'm going to go back to my information. Negative 3 is here in the middle. Negative 3 says I'm supposed to touch the x-axis. So I'm going to touch, meaning I'm going to bounce back up. I'm not going to cross. Alright, and then I'm going to hit 0. So go back to my information. When x is 0, this time I am crossing. So now I'm going to cross the x-axis and bounce back up. And then go to my information at x equals 5. At 5 again, I'm crossing. So that makes sense, and I'm going to match my arrow up there. And that is a rough sketch of your polynomial graph. Now point out, let me make a note, that these humps right here and right here, I actually don't know how high or short to make them. And that's okay, we're just doing a sketch of roughly what this polynomial looks like. You'll get to know that information when you get to calculus.